Well, hello. It is I, Mr. Bertoch, your extremely handsome science teacher. In this video, we are going to be talking about the rock cycle. One of the more interesting aspects of the Earth and of science is that the Earth is constantly changing, meaning that the surface of the Earth is really never the same from, I'm going to say moment to moment, but keeping in mind that I'm talking about geologic moments, which span, tens of thousands of years, if not millions of years. But the Earth is constantly changing. What the surface looks like today is not what it looked like millions of years ago. And one of the forces, I guess, one of the primary things that is happening as the surface of the Earth changes is this thing called the rock cycle, where rocks are changing from one type of rock to another type of rock. And this is an ongoing process that is constantly happening all around us all the time, although compared to our lives, the spans of our life, it's happening much more slowly than us, but still, the rocks we see around us are changing from one type of a rock to another. Now, before we talk about the rock cycle, it's important to recognize that this is not the only cycle that happens. There's, and I'm sure you've heard of the water cycle. And there's the water cycle where water is moving around and changing from solid and liquid and gas. There's the carbon cycle and the phosphorus cycle and the nitrogen cycle. Okay, and there's other cycles as well that occur on the Earth where substances are moving and changing from one place to another. And rocks are no different. Just like with the water cycle, where water moves and changes, so too do rocks. And yes, rocks do even move from one place to another through weathering and erosion, which I've talked about in another video in much more detail, but I will briefly talk about in this video as well. So let's start with what are rocks. Rocks form when magma from deep within the Earth comes either to the surface, where it then cools down. That might be through some sort of volcanic activity, or very often it actually just cools down underneath the surface of the Earth and hardens. Okay. When magma cools down and hardens, we call it crystallization, and that is an important sciencey word that you need to remember. Crystallization is the process of magma cooling down. If magma cools down quickly, we really don't get a lot of crystals, we think of as crystals, forming. But if magma cools down slowly over thousands or tens of thousands or even millions of years, the slower it cools down, the more crystallization we see and the bigger the crystals actually are. So when you see a rock like granite, for example, that has a lot of specks in it and some sparkliness, okay, granite is a common rock that forms underneath the surface of the Earth. We know that it cooled down. It must have cooled down very slowly so that crystals could form. If you see a rock that is mostly all one color, like black or red, then that probably cooled down on the surface very fast in a matter potentially of a few minutes or a few hours. And so it didn't have time to really form any crystals, but we still call it crystallization. When magma cools down, the type of rock that forms is referred to as igneous rock. Igneous rock is the first kind of rock that all magma starts as. Okay, it cools down from magma or lava, but it's magma when it's under the surface, and it forms igneous rock. And there are a few different types of igneous rock. There's extrusive, meaning it's on the surface, and intrusive, meaning it's underneath the surface. And as based on the conversation that we've already had, you can predict that intrusive rocks under the surface are going to have a lot more crystallization than extrusive rocks, but they're all types of igneous rock. Okay, rocks don't stay as igneous rocks. I mean, they might, but very often they change under certain conditions. Okay? One way that rocks change is that they are put under tremendous pressure and heat, and they melt, or maybe there's chemicals present in the rock that do like mini science experiments. They chemically alter the rocks, and they change them from one type of rock to another. That new kind of rock that forms as a result of heat and pressure and maybe chemicals that are present is called metamorphic rock. Metamorphic is a fancy sciencey word that means that I have an itchy nose. No, wait, that's not what it means. It means that it is changed. Metamorphic means to change. So if something morphs, it's changing. Okay, so we change the rock from igneous to metamorphic rock. And there are a lot of kinds of metamorphic rock, just like there's a lot of kinds of igneous rock. There's granite as an igneous rock, and there's basalt, lava rock. There's a lot, andesite. There's a lot of kinds of igneous rock. And depending on what kind of igneous rock we start with and what happens to it, did we add heat? Did we add pressure? Did we add chemicals? Will determine what kind of metamorphic rock we end up with. It's just kind of like, think about taking ingredients like flour and eggs and putting them in the oven and cooking them. Well, I might get a cake or I might get a bagel, right? It just kind of depends on what ingredients I started with and what I did to those ingredients to get what I end up with when I take it out of the oven. So an example of a metamorphic rock is called gneiss, and it's actually kind of a cool rock and looks kind of pretty. And it's when you take granite, you start with granite. That's the ingredient I'm starting with. And I am melting it and applying pressure and rearranging. The crystals are all aligning with each other, and they start to form these layers, and they look still kind of like granite, but also different. Okay. And then there's another kind of rock, which is called sedimentary rock, which forms when weathering and erosion occur. In another video, I talk about weathering and erosion. Weathering is the process of breaking rocks down into smaller and smaller pieces, and erosion is a process of carrying those pieces away and eventually depositing them somewhere, very often in a bottom of a lake, okay, or in the ocean. And when these pieces are deposited, these little tiny pieces of dust and sand, eventually they cement. Through cementation, they form new rock called sedimentary rock or sedimentary rock. And this new rock is solid and hard and kind of rough filling. It covers sedimentary rock. Sedimentary, either way is right. There's not a right way to say it. Covers 75% of the Earth's surface, but yet it makes up only 5% of the total rock. It's just that the most of the surface of the Earth is covered with it, but it's most of the underneath the surface is still igneous rock. Okay. So there is no exact path through the rock cycle. Rock might start as igneous rock, and it might go straight from igneous to sedimentary rock, or it might go from igneous to metamorphic. It can take any path. And by the way, it can go back to igneous because perhaps it will be melted again. Sometimes rock is through plate tectonics, subducts back down into the mantle of the earth, and it melts and it becomes magma again, and it starts the whole process all over again. Or a little bubble, a little flume of magma bubbles up through the crust, and it melts rock as it goes, and it changes whatever form it was in back to magma, and then ultimately starts over as igneous rock again. Okay, so rocks are constantly changing from one type of rock to another. There are three main types of rock, which are igneous, metamorphic, and sedimentary, or sedimentary, depending on your preference, your preferred way of saying it. And rocks are changing from one kind to another between these. The important words are crystallization, which means to solidify. Also melting, but that's not a hard word to remember. Okay. Weathering and erosion are important words. Deposition, which is when the little particles through erosion are deposited somewhere. And we probably ought to talk about real quick about the law of superposition as well. Let's do that. Okay, the law of superposition is something geologists use to help to date things when they're looking at layers. You will notice when you look at sedimentary rock or sedimentary rock, you will notice that there are layers, and the layers show you different time periods. Well, we can, as scientists, we can infer that the lower down layers are older than the higher up layers. Okay, because as erosion occurs and it carries dirt and sand and stuff in, it deposits newer layers on top of older layers. That's very logical to think about. Okay, as a stream is running and it's carrying sediment in, it's going to deposit the new sediment on top of the older stuff, which will be below. So it's common sense that the newer layers are going to be on top of the older layers. And so this is called the law of superposition. And scientists use this to date things. It's called relative dating. It's not when you date your relatives. That would be weird. It's when we look at the layers compared to each other, relative to each other, and decide which ones are older and which ones are younger. We don't know the exact age of the layers, but we know that the ones on top are younger and the ones on bottom are older. So that is the law of superposition, and that is the rock cycle. Hi guys, thanks for watching my video. These rambling science videos where I go unscripted and just kind of barf up all the science knowledge out of my head are part of a series that go along with an online class that I teach, which you can sign up for if you go to handsomescienceteacher.com. I also have a whole bunch of free resources for homeschoolers. I have hundreds of articles on every topic that covers your entire science curriculum from 5th through 8th grade. I have online games and quizzes, all curated and written by this handsome guy, a science teacher with, well, three degrees, but 2 of them are in science. So it's targeted right to and directly to your science students. So sign up, subscribe to the channel, and I release lots of videos. Also, in addition to these ones, lots of little short videos that are like 2 minutes long that cover science topics. Those ones you don't get to see my handsome face, but they're still good videos, and they're much more targeted, and those ones are scripted, so you don't have to hear me like you are right now going blah blah blah. The end. Subscribe. Thank you. Goodbye.